this video, I'm going to show how to set up a C development environment in Visual Studio Code on Debian using CMake and Clang. Step 1 will be to install CMake and Clang. We will do this with sudo apt install CMake Clang. I have already installed these, but for the purpose of the video, there you go. In order to start a CMake project, you need a CMake main file. In CMake, this is called CMake lists.txt. First, in this file, we have to declare the version compatibility. This is done with CMake minimum required. I've chosen 3.20 here, but you can quickly do CMake version in your command line to make sure that the one bundled with your operating system will satisfy this requirement. Next, we need to start a project. To do this, use the project command. You can see here I've created a project called tutorial, and its languages are C. There will typically only be one project per CMake, but it can really depend, and things can get a lot more complicated. Finally, in order to finish out building an executable, we need to add one. Use the add executable command to add an executable target to the CMake file. What we do here is give it a name. We'll call it tutorial. This will be the actual name output by the compiler when this is finished, and its input of main.c, which we don't have yet, so we'll go ahead and create it. So I've gone ahead and created a simple main.c file. Now, let's get this building. The first step to build a CMake project is to configure it. The configuration step is where CMake generates the build files and does any other pre-build configuration required by the project. CMake's default mode is to configure, so let's go ahead and do it now. Let's talk about this command. I'm invoking CMake, passing this directory as the source, and this directory as the build directory. CMake does what's called an out-of-source build. This means that it places the build object files, or build output, in a separate directory tree from the source. This is often a very, very good thing, and for those of you who have worked on larger projects, you will know why. So we'll go ahead and invoke this command line. You see here that it builds and says the C compiler identification is GNU 12.2.0. So we installed Clang and want to use Clang. How do we force CMake to use Clang instead of the GNU toolchain? Well, we can simply use an environment variable. Now, if we build again, you will see the C compiler identification is Clang 14.0.6. We're using the correct compiler now. So what actually happens in the configuration step of CMake? As we can see, it's generated a folder called build. Inside this folder, you'll see a make file and a cache, as well as a bunch of CMake files. CMake is what's known as a meta build system. It does not actually directly build your resultant files. That is handled by another tool, in this case, Make. That is the default on Linux. It can also generate Ninja files, it can generate Visual Studio projects, and many other output files. This is very useful because it allows you to have a single CMake list.txt to generate the build files for many different platforms, including ones you don't necessarily support at the moment. This means something quite cool. If we change directory into build, we can call make to build our project. We can now build everything without invoking CMake. In future tutorials, I will cover more about the CMake files and more about C. This series is going to eventually delve further in and maybe even cover things like embedded systems development.